Hey Calculus, welcome back. Our objective today is to be able to find derivatives of products and quotients by hand. I'm going to force a pause on your screen. You know what to do. Alright, I'm going to force another pause on your screen. Will you please write this down, that the rules for derivatives of products and quotients of two functions do not work like sums and differences, okay? So go ahead and write that down as well as the two expressions I have on my screen. Okay, so what do I mean by this? Well, I mean that if I gave you y equals x squared plus x, and I want you to find the derivative, you can just go term by term, right? And take the derivative of x squared, which is 2x, and the derivative of x, which is 1, and that would be y prime, right? Let's try applying that same logic to x squared times x, okay? So if I try to find the derivative sort of term by term here, if you will, and multiply them together, the derivative of x squared, we said, is 2x, times the derivative of x is 1, and that's equal to 2x, right? Okay, let's test that and see if that's the correct derivative. Okay, I'm going to put a question mark there. So let's rewrite what we have. What we have is equivalent to x to the what? Now that's x cubed, okay? So we know the correct derivative is actually what? 3x squared. Is that what we got here? No. Okay, so I can tell already something is up here, right? Something is not going quite right. Let's try the same thing here. So let's say x squared divided by x. Well, that is equivalent to just x, right? So the correct derivative should be what? What's the derivative of, give you a hint, 1x. The slope of that line is always 1, right? If I try to take the derivative of the numerator over the derivative of the denominator, I would get 2x, which is the derivative of the numerator, over the derivative of the denominator is 1, which again, that is not equal to the correct derivative, okay? So, something's up here. If I have a product or a quotient, I'm not going to be able to take the derivative of, for example, the numerator over the derivative of the denominator and get the correct answer, okay? So let's take a look at what are we supposed to do. All right, so product rule. Will you write this for me? If I have a function, and I will call it h of x, if h of x is equal to some function times another function, okay, I know that h prime is not equal to what? It's certainly not equal to f prime times g prime, okay? Here is how I find h prime. I take the derivative of the first function, then times, and I hold the second function, okay? Then I plus. Now I do the opposite. I hold f of x and multiply it times what do you think? The derivative of g, okay? So this is how I remember it. When I take a derivative, I call that messing the function, and that is actually, there's mathematical justification behind that. We'll talk about it. So I say mess the first, in other words, take the derivative of the first function, hold the second, in other words, just keep the second, bring it along for the ride, plus, and then switch it, yeah? Hold the first, and mess the second. Okay, all right, let's put this into practice. So let's take a look at that previous one we had. We had x squared times x, right? And if I come back here, we should get 3x squared as the correct derivative, okay? Well, let's try applying product rule to it. So mess the first, I would get 2x times, hold the second, okay, then plus, hold the first, x squared, times, mess or derive the second, which is 1. Okay, let's simplify this. 2x times x is 2x squared, plus x squared times 1 is x squared, and then 2x squared plus 1x squared is 3x squared, which is what we know is the correct derivative, okay? All right, so let's go over the proof. All right, so you do not need to rewrite all of this. I would like for you to watch at least, because we have a hunch that this is going to work for us, but I've only given one example. One example does not a proof make. So let's prove that this product rule works. So if I want to find the derivative of f times g, then I know that that's equal to the limit as h approaches 0 of f of x plus h times g of x plus h minus f of x times g of x all over h, right? That's the formal definition of the derivative, okay? So what I'm going to do is right in here, I'm going to subtract something and then add it back in, which doesn't change anything, right? So now I've got the limit as h approaches 0. I'm keeping that f of x plus h times g of x plus h. Okay, now I am going to subtract f of x times g of x plus h. And if I subtract that in, I better add it in as well, right? So I technically haven't changed anything. Okay, and then I still need to come back and grab this part of minus f times g. Okay, looks like you just made it more complicated, right? Okay, however, now what I'm going to do is split this fraction in half right there. So if I take a look at this part, those two terms have something in common. They have what in common? They have a g of x plus h that I can factor out. And what's left is f of x plus h minus f of x all over h. Looks familiar, right? Okay, and then if I take a look at that part, remember that's still all over h. What does that part of the numerator have in common that I could factor out? Yeah, that part I can factor out n f of x. So what's left is g of x plus h minus g of x all over h. Should also look familiar, right? So now let's apply the limit to the two pieces of the difference. So because g and f are differentiable, g is certainly continuous. So if I plug in 0 there, that's going to give me g of x. If I take the limit of this piece, that should look familiar. That's f prime of x. That's literally how I define the derivative, okay? Minus, now I've got f of x, and then again, if I come here, the limit of all of that as h goes to 0 is g prime, right? Also known as the derivative of the first times the second plus, the first times the derivative of the second. Okay, so there's our proof. All right, so I'm going to force a pause on your screen. Let's bring this up a little bit. Can you write h of x on your screen? And then we will do this together. All right, so it says example 1, find the derivative. Be sure to label what you're finding and watch out for linkage errors. Okay, so what am I finding? I'm finding h prime, and I know I need product rule here. Why? Because I have a product of two functions, right? Now you could certainly distribute everything and combine like terms and go term by term. That would be fine as well, okay? But we will add more functions to our arsenal where distributing isn't going to work for us when we add in like trig functions and such, okay? So formula, derivative of the first, right? So what's the derivative of 3x minus 2x squared? Well, 3 minus fly the 2 to the 2, 4x, right? That's the derivative of the first. Then we're going to hold the second, 5 plus 4x. Then plus, now I'm going to hold the first, 3x plus 2x squared, times derive the second. Derivative of 5 is what? It's 0, and the derivative of 4x is just 4. I'm going to ask that you leave it like that because we're just practicing product rule here. All right, so that's products. What about quotients? What if I have a function over another function? Okay, so if h is equal to f of x over g of x, then h prime, the numerator is going to look really similar to quotient rule. I'm sorry, to product rule. So I take the derivative of the first, hold the second. In this case, first is numerator, second is denominator. But now instead of a plus, what do you think I have? I have minus, and then reverse, hold the first, derive the second, and then here's kind of the funky part. It's all over the original denominator squared. Okay, and we will prove this after we look at chain rule next week, or in a couple weeks. Okay. So how do I remember this? Well, it's like product rule, except what? Except a minus instead of plus, and all over the original denominator squared, right? Those are the two, basically, differences between the two rules. All right, I'm going to force a pause on your screen. Will you please write this function, y equals 5x minus 2 all over x squared? Okay, so now we are going to find the derivative. So I'm going to call this y prime. What rule do I need here? In quotient rule, because I have a function over another function, okay? So we're going to derive the first, which is just what? It's just 5, yeah. Then hold the second, which the second is the denominator. Now what? Now minus. Now hold the numerator, 5x minus 2, and derive the denominator, which is going to be what? Just 2x, and then all over the original denominator squared. Okay, for these, I'd like for you to simplify the numerator, leave the denominator as is, okay? So if I distribute here, I am going to get 5x squared plus 5. Now be really careful with that second part because you have a negative being distributed from this side and the 2x from that side. So think of it as distributing a negative 2x. Okay, so I would have negative 10x plus, sorry, negative 10x squared plus 4x. Okay. All right, so final answer, my numerator here when I combine like terms, I've got negative 5x squared plus 4x plus 5 all over x squared plus 1 quantity squared. Good deal. All right, for our last example, would you please write these in your notes? All right, so my caution here is use these rules sparingly. In other words, if you can avoid, especially quotient rule with a rewrite, it is really going to make your life easier if you can kind of think, hey, is there some algebra I can do here before just assuming a quotient rule, okay? And we can do that when you've got either a constant or some kind of power function and only one, so only one term in your denominator, okay? So for example, for g of x, dividing by 4 is the same as multiplying by a fourth, right? So I can think of that as 1/4 x to the fourth minus 7/4 x squared. And now I just have good old power rule. So now g prime is equal to, if I fly that 4 to the 1/4, those actually cancel, right? So I've got x to the third minus, flying the 2 there, I've got 14 over 4, also known as 7 over 2, x, okay? And then I'm done, and I totally avoided quotient rule, okay? What do you think I can do with f of x? Well, to rewrite this, I can rewrite that square root of x as x to the what? Negative 1/2, right? then I have 2x plus 7. But now I just changed a quotient to a product, and I'm trying to avoid these rules. So what can we do from here? From here, we can distribute, right? So I can get 2x. If I add those exponents, I have a positive 1/2 plus 7x to the negative 1/2. Okay, is that the derivative? That is not the derivative, but now I have just good old power rule from yesterday. So now I can fly the 1/2 to the 2, which is 1, x to the new power of negative 1/2. Now if I fly the negative 1/2 to 7, that's negative 7/2 x to the negative 3/2. And then I'm done, okay? Okay, so as our final example here, I am going to leave you with this. Then I would like for you to bring this to class and see if you can fill in the last 4 squares here. Okay, I've given you f prime, g, and g prime. H is defined as the product, J is defined as the quotient. See if you can fill in those last 4 squares and bring those to class for me. All right, bye you all.